Welcome to InnoBuzz Java Video Tutorial Part 6. In this chapter, we will see the abstract classes and methods. In the previous chapters, we have learned how to create classes and methods, how to write the program parts that tell the behavior of our objects in the classes that contain the fields. These were all concrete classes. We have seen how to make child classes from superclasses, and we have seen how to override and overload methods. The abstract classes are different from these concrete classes. We are going to see in this chapter in what way they are different. Let's make an overview. First, we will talk about the polymorphism in general that we have mentioned in chapter 1. A little bit more detailed, we will talk about it now, because this is an important thing about the abstract classes as well. And we are going to talk about the abstract classes in details then, the abstract methods. We are going to discuss when and where to use the abstract classes and methods then. And at the end of the chapter, we will talk about final classes and methods. We will talk about polymorphism now. As we have mentioned in chapter 1, polymorphism is the ability of an object to take on many forms. In Java language, polymorphism is the capability of an action or a method to do different things based on the object that it is acting upon. We have seen in the previous chapters how to overload methods. The overloaded methods have different signatures, so this way the compiler can make a difference between them. There are also overridden methods. These methods have the same signature, but one of them is in the parent class and the other is in the subclass. And the one in the subclass, which is the same name and absolutely the same signature, can override the method in the parent class. Now let's see how it looks. We have a superclass with a method. There are some subclasses, which are the child classes of this superclass. They have the same methods, the same signature, and wherever we use these, the Java compiler will have to know which method to use. Now this is the polymorphism, that we have different implementation of the same method in the subclasses. The Java compiler allows us the dynamic method binding, so it can resolve the references, the subclass methods at runtime. Let's see an example now. In some class, we declare two variables, two objects from the superclass. We declare here them, and then we instantiate them with the subclasses. The subclasses extend the superclass, so this is going to be a good initializing for them. But then, when we call the method from one of these objects, the Java compiler will know that which object, which variable should use which method, and it will call the method that is declared and implemented in the subclasses. Now this is about the polymorphism. Let's do some practice on polymorphism first. We are going to use the same classes as we used in the previous chapter, in chapter 5. We have the person Java here that we used. Now I'm going to create some classes that will extend the person. What kind of persons will we have? Well, let's say something like guys, or just a guy. This is the guy Java. Okay. Yeah, we say public class guy extends person. Okay. Well, let's say that we have a constructor here. I copy it from here. But this time we won't get the gender because it's a guy, so it's no question. And we will see that super and we say we use these parameters. So I'm going to create a new class here that extends, and I say that it's gender dot male. Now this is it. This way we already created a guy. This has all the methods and everything that are here. This can reach everything. The difference is only this. I create another one with the float height. And I'm going to use the other thing. Yeah, this is it. I save it. We have the guy Java. This is the way to create guys from now on. We are going to create girls as well. Girls. Girl. Okay. I simply copy everything. I copy it and I say that it is a girl. And we say that gender dot female. Yeah, and of course extends person. So now we have the girls as well, which are females, of course, and that's it. This way we can already create girls and guys here. Okay. Now let's make some polymorphism here. Well, I found out something which is a little bit similar to this mass index thing. I write it to the end. I say that public float ideal body weight, or get ideal body weight. Well, let's see that this is the get height minus 100. Return. Yes, let's check it. The get height. Yeah, it's in integer. We use the height in centimeters. So I say that if someone is 1 meter 80 tall, then he should be 80 kilos. This is a very simple way to do it. Yes. But what happens if you want to specify this for girls and guys? I want to override this. I say that, of course, I copy. I say that something, for example, for guys, well, let's do something different. Yes. And the NetBeans shows us that we should write an override annotation. This is a very good way. Yeah. So this way we can show that we are overriding the method which we got from the parent class. So it works anyway, but this is the best way to explicitly tell that we are going to override something here. Well, let's say just for the code, let's say it's 95 or something. So okay, guys can be a little bit bigger or something. I hope that these extra kilos will be in muscles. So yeah, this is just about the method overriding. So overriding for the girls, well, I will use something different, like well, get height minus 100 and minus get height divided by 10 20. So they should be a little bit, very little bit lighter, but I hope that no one is going to be mad at me about this. Well, yeah. So this way we have different codes for everyone. Now let's create them. We have the guys here, they are persons, but I say that new guy from now, and I don't have to use this anymore. New guy, John, and also Ben. And the girls, new girl, girl, all of them. Okay, now we have all the girls and boys, and as you can see that we create arrays of persons here. We use everywhere persons, but I can put the girl and the boy or the guy into them because it works with them. So this is a parent class, and it's okay. The names, I think it's okay, and also I should perp get name. I say that the ideal weight of this person is per dot get ideal body weight. Now let's see what we will get. I save it and I run. The ideal weight of Chuck is 83. Of John is 63. Wow. Well. Well. Do I like these numbers? I don't know. Elizabeth is tall. She's 65. Okay. Okay. This is good for an example. I could specify it a little bit more, but it's okay. I could have written their real weight as well. I do it. But the real weight is get weight. Okay. Just to be able to compare, but the real weight is, well, they are close. Okay. They are close to each other. Okay. Now this was the polymorphism. So this way we can see that every object knows that what kind of which method to call. I could do something like to get more extreme. to get more extreme things. So I could do something like, yeah, I know what the problem is. I should have done this. I think no. I think it's okay like this. But if I write here maybe 2, then we will get very thin girls. I guess. Yeah, they are in minus. So what we wanted to see is that for all the girls, this is the method that is called. So they are very anorectic, or I don't know how to say. They all have anorexia. Okay, so they can see that the guys have normal weight, so that this is called for them, and this is for the girls. But I give it back. I don't like this anorexia thing. Okay. Now this is about the polymorphism. Let's see now what the abstract classes are. Abstract classes are special kind of classes. In the declaration, they start with the keyword abstract. What is so special about them? Well, these classes cannot be instantiated. They can only be subclassed. Let's see. There's an abstract class with a class name. It can contain also concrete fields and methods, and also abstract methods. So there can be field declarations inside it, constructors, non-abstract methods, and also some abstract methods that we are going to talk about in the next slide. So the specialty about this whole thing is that we cannot make an instance of this class. We have to make a subclass that implements all the methods, all the abstract methods that are inside this. Now let's see the abstract methods in details. The abstract methods look like this. This is they start with the abstract keyword as well, and we tell the return type, the method name. We give the parameters just like in other methods, but at the end there is only a semicolon, and there is no body, there is no code inside it. So it has no implementation. It has to be implemented in one of the subclasses of the containing class. If there is an abstract method in any class, then the class also has to be abstract. Now let's see some notes about it. Don't forget that there are no braces because there is no implementation, no body. Ends with semicolon, and the implementation is in subclasses. We will see in practice how they work. When and where to use these abstract classes and methods? Well, these can be very useful when we are writing programs. If we want to create a good object structure, a good class structure for ourselves. As we've mentioned, these are not for instantiating, these are for subclassing. This means that we have to use the abstract classes when we want to collect together some classes that will belong to a parent class. So when these classes belong together in some way. They can also contain partial implementation. So if we are collecting together all the typical attributes of some classes, and there are some things that work in the same way, then we can create concrete parts, concrete fields and methods as well. We can share these fields and methods with the child classes, with the subclasses, so they can work in this way just like normal classes. They can have the concrete and the abstract methods in the same time. So this means that these abstract classes are in halfway of being totally abstract and being concrete a little bit. They can implement interfaces. Well, about interfaces we are going to talk in the next chapter, but they are totally abstract things. And it is important that abstract classes can implement them. We will see it in the next chapter. I wanted to talk about finer classes and methods in this chapter because they are related to the abstract classes in some way. As I see, they are almost the opposites of it. The abstract classes are somewhere close to the top of the hierarchy of the classes. If we see, for example, as a tree, because they are mostly the parent classes of subclasses. So they are in the top of the hierarchy some way. And the finer classes and finer methods are mostly the leaves of this tree. So they are at the end of the hierarchy. Why? Because we cannot change them. So the finer class, we cannot be subclassed at all. So if we have a finer class, then it's unchangeable. No child classes. Finer class, class name, and then comes the body of the class. So it's only one keyword difference. There can be also methods that are final. Final, void method name, or final and the return type method name, and the body and the code of the method. If we use the final keyword in method declaration, then we indicate that this method cannot be overridden in the subclasses. So this is the final version of the method. Well, this can be useful in situations, for example, when we want to create immutable classes. Or sometimes if we want to implement codes that we don't want anybody to change later on, because they contain consistent state of objects. Let us now continue on with the same project here, person, guys and girls. But this time we are going to create abstract things. Well, person Java, I'm going to make abstract. What do I have to do? I write here abstract. And that's it. I can save it and it's already abstract. Well, it has these fields and everything inside, the constructors and everything. They are already all good. What I really want to change is this. The float, public float get ID body weight. In the previous demo, I didn't even use this. So I used the one that is inside guy Java and the one in girl Java, but this we didn't use. We don't even need this. So I only need to make abstract of it. Public abstract float get the ideal body weight, and I don't need the body of this anymore. So this is a method that is an abstract method, and we are going to write the code only here. That's it. And maybe we don't even need this anymore. Well, it's better to use it. So we have the body weights here. We get ideal body weight here. I saved it. Okay. So this is an abstract class from now on. But as you can see, there's only one abstract method inside of it. This. And if you run it, from now on, I cannot say that, for example, I want to create a person, like new person, because it's an abstract class, so it cannot be instantiated. I cannot say that person, girls, and well, a new person, even if I add the extra parameters here, no. It's abstract, so it cannot be instantiated. That's it. But I can use these variables here to be person, because this is the abstract class that these instantiate it. So it collects them together. So everything is working in the same way as before. I run it, and we get the same result. The average body mass index and everything. I wanted also to show you the final. For example, if we say that we are not going to create any classes out of the girl, it extends person, but there is not going to be any class that extends girl. Then we can say it's final. Public final class girl. That's it. And also we can use it here. Public final float. Yes. So if we save it and we want to create a new Java class, like, I don't know, little girl, and we say that this extends girl. Cannot inherit, we can see, cannot inherit from final test project dot girl. Okay, there's no constructor, but I don't want to write it anyway. So it's not possible. But even if I change this back and write the constructor, little girl, well, super. Now we need the parameters as well. Where did the height go? Hmm. Okay. So even if I do this, save it, I cannot say that I overwrite this. Yeah. Cannot override it because it is final. So that is about the final things. So this is not okay. I don't need this little girl thing at all. Just the big girls.